Amazon EKS makes it easy for teams to run resilient, fault-tolerant Kubernetes clusters, but that only applies to the control plane. We still need to design our applications to take advantage of high availability. This means ensuring that our workloads can start and shut down quickly, migrate between nodes, and tolerate unexpected outages without causing cascading failures. In this video, we'll show you how you can use Gremlin to make your Kubernetes applications more resilient. Gremlin is an enterprise chaos engineering SaaS solution that helps teams like yours build more reliable systems in a simple, safe, secure, and comprehensive way. With Gremlin, you can simulate failures in your Kubernetes clusters in order to address weaknesses and build resilience. First, let's set the stage. We have a 2-node EKS cluster running an e-commerce website that consists of 10 different services. Each of these services provides critical functionality such as retrieving product data or processing payments. As an e-commerce site, uptime is paramount. According to Gartner, we could be losing over $300,000 per hour of downtime, so we want to make sure that these services are as reliable as possible. Using Gremlin, we'll test the resilience of our application by deliberately causing a service to fail. We'll observe our application to see how it responds, then use these observations to identify failure modes and address them. Here is our website. I can browse products, add items to my cart, place orders, and so on. These features are working great right now, but what if something unexpected happens? Maybe we have a latent bug in our code that causes a pod to crash, or an engineer accidentally sends the wrong command and takes down a node. Are our applications and systems built to adapt to problems like these? Or will our website go down? With Gremlin, we can test these scenarios in a safe and controlled way. In this example, we want to make sure that our website is still operational even if we lose a critical pod. To do this, we'll use a shutdown attack to terminate the pod that manages our product catalog. If our deployment is configured properly, the pod will automatically restart and it will be business as usual. If not, then we'll have identified a weakness in our application that we need to address. Let's run the test. I'll open the Gremlin web app, create an attack, and expand Kubernetes resources. Under Deployments, I'll select Product Catalog. To the right is the blast radius, which is the set of resources included in this attack. We can see that we only have one instance of the product catalog running. Under Choose a Gremlin, we'll select State, then Shutdown. We'll uncheck Reboot, set the delay to 0 so the attack starts immediately, and then click Unleash Gremlin to start the attack. If we use the Kubernetes command line to look at the product catalog service, we'll see that it was restarted once. This means Kubernetes detected the terminated pod and immediately provisioned a new one to take its place. This is reassuring, but there's still the potential for a delay between when the pod fails and when Kubernetes replaces it. This might be fine for a small, low-traffic site, but it will be noticeable in a site with a lot of active users. To address this, we should scale up our product catalog deployment to at least 2 or more pods for redundancy and for horizontal scalability. Let's do that now. Now, if we terminate one of these pods, Kubernetes will route customer traffic to the other pod while the failed one is replaced. We should repeat this experiment with our other core services such as our front-end, shopping cart, checkout, and payment services to make sure they can tolerate outages as well. Downtime is a possibility with any system. Just because our clusters are designed for high availability doesn't mean our applications are. By proactively testing for failure with Gremlin, we can provide a smoother, more reliable experience for our customers. Prepare for the moments that matter at gremlin.com/Kubernetes.